Hello again and welcome to this YouTube channel. Okay, now we move forward to the application part of our critical point, okay, our maximum, minimum, and so on. But now we are not looking at the function anymore or the graph. Okay, so we start with a simple application first. All right. So if let's say you want to find the largest area of a rectangular, okay, and then you know that you have part of it, you know that you have a perimeter of 100 meter, all right, put all together. So this is a like a simplified question, and then you need to find the x and also the y, the largest area. So how can you even start? All right, first things first, you know what is a rectangular. Okay, so to be safe, this is your rectangular. Sorry. All right. Just assume it is a rectangle. And then you know that your side here and your side here is a little bit different, right? But you don't know whether you want to find it, whether it is a square or or a rectangle. Okay. We need to see what is the best way for us to find the largest area possible, okay, in this case. So we know also that our parameter is 100 meter, meaning that the rest of this whole rectangle, you have 100 meter put together. So our main first idea, we know that the side here and the side here is the same. So we safely say x, and then we know the side here and the side here is also the same. So we just put y over there. And then from here, we build slowly, all right? So the first thing that we know is that if we have 2x, meaning that I total summing up every rectangle area, okay, not area, the perimeter, meaning that if I have 2x plus 2y, it must equal to 100. Correct? Makes sense, right? Because I have this plus this and plus this. This is a parameter. Okay, so that one is clear. And then my issue now is to find the area. Okay, we know that area is just the one side multiply with another side, right? So meaning that this is my area. So actually I want to know what type of area that I have over here. So now, can we proceed to do just this? Okay, the idea is that we have two different variables together, right? X and also Y. So, but earlier we didn't learn about the multi-variable calculus. Okay, we just learned about one single variable X. Everything we have X. So, how to do just that? We utilize the value that we have. Since let's say we want to focus our intention into X, now we can make full use of my value over here. And let's say I transform this into a X kind of ways. Okay. So how to do just that? I know this is just the same, right? This one, 100 minus 2x. And I know once I have this, my y is actually just 50 minus x. It's the same, right? Okay, I just rearrange the calculations so that I can, okay, eliminate my y. Okay, that's my intention. Now in this case, let's say my area now, instead of writing like this, okay, I write into a function form. All right, and then my x is the same, but now my y is just a function of my x. Now this is the value that I have. So in this case, you can see over here, I have a mathematical function right now. Once I have a mathematical function, that means I can utilize my knowledge on finding either a maximum or a minimum points, all right, just by using my knowledge on differentiation. Okay, so in this case, if let's say this is my function, okay, can I find the maximum or minimum point? Can, right? Because I know if I can get my critical point, definitely by using this critical point, I can test whether it is a maximum or a minimum point, right? So basically, I'm using that knowledge. I put the prime for my f, and then my value now becomes 2x. And then I know I can safely say this one equals to 0. And then suddenly I get my x equal to 25 lah, right? 25. Okay, and then I know if I get x equal to 25, what about my y? Okay, my y, I put in the original values there. My y also 25. Okay, so now this is the value, all right? This is the critical value to make sure that my points is extremum. Okay, so that one is clear. But now my question is actually to find the largest area. Largest meaning also the same as maximum points, all right? So we test. Okay, my f prime earlier is 50 minus 2x. Now we test whatever happened for my f double prime. Okay, so now in this case, my f double prime is just minus 2. Correct? And then minus 2 is actually less than 0. Once minus 2 is less than 0, we can get that, oh, actually, this value will portray my maximum. All right, my maximum. Okay, relative maximum in this case. So when I need to find the area, I know my value, my x equal to 35 is actually a maximum, meaning that the largest area for a rectangular to becomes. All right, so I know my area earlier is equal to xy. So my largest area now is all the value that portray by my critical point, which in this case, my x 25, okay, and my y is 25. All right, and then you multiply together, you get 265. So actually, this 265 meter square is your largest area for your rectangular right now. Okay, interesting, isn't it? Okay, so I hope you enjoy the lesson. This is how you're going to reduce the complicated. This example, even though it looks simple, but this is the way you're going to translate, okay, your knowledge on few area that you know, your prior knowledge, okay, you're putting your prior knowledge into action. Okay, so that is how you're going to utilize all your available information in one particular short sentence into a mathematical formulation that you are now able to solve. Okay, so I hope you enjoy this video. I'll see you guys in the next video. All the best.